Greetings, students. Mr. Harrison here from school. I'm going to walk you through the elements, compounds, and mixtures slideshow for this matter unit. So let's get cooking. Okay, first thing, we've got pure substances. And what that means is that that particular sample of matter has definite or fixed, unchanging physical properties. So there's actually two different kinds, and we'll get to that as we go through this. But matter is any substance which has mass and occupies space. And by the way, occupying space is the definition of volume. So that could read that matter is anything that has mass and volume. So the first type of pure substance is called an element. And an element is a pure substance that can't be separated into a simpler substance by physical or chemical means. So you can't physically break it apart into simpler substances, and you can't put it through a chemical reaction to make it into simpler substances. Very, very hard to turn an atom into something other than what it already was. Therefore, it's very hard to turn an element into something that it wasn't already existing as. The only way to do that is with a nuclear reaction. So a couple of vocabulary hoops to jump through here. An atom is a small unit. As a matter of fact, it's the smallest unit of any element that can maintain that element's properties. So once you break it down further, it's no longer that thing. It's something else. And again, that requires a nuclear reaction. Then you've got molecules, which are composed of two or more atoms that are joined by chemical bonds. So in order to break a chemical bond, you need a chemical reaction to break it apart. These molecules that are bonded together can be of the same atoms, like H2, which is hydrogen gas, O2, which is oxygen gas, and N2, which is nitrogen gas. Three very common gases in the atmosphere. Nitrogen is the most common. And those are called diatomic molecules, di meaning two. So H2 right here, and O2 and N2 diatomic molecules. Or they can be molecules of different atoms, which is like the C6H12O6, which is what we have right here. Excuse me, I had to get that bar off the bottom. C6H12O6 is glucose, and then H2O, it's kind of hard to see. So there we go. All right, and compounds are pure substances. Pure substances, don't forget that part. It seems a lot of people think they're not pure substances. They are pure substances, but they're composed of two or more different elements joined by a chemical bond. The most common one of these is H2O, which most of you recognize as water. This is two hydrogen atoms and one oxygen atom joined by chemical bonds. It becomes water. And they're made of elements in a specific mathematical ratio, and that ratio is always the same. For instance, water, H2O, will always have two hydrogen atoms and one oxygen atom joined together. You're never going to find it as H2O2, that's hydrogen peroxide, the brown bottle of bubbly stuff you put in your cuts. You're never going to find it as HO2. It's always going to be two hydrogens, one oxygen. Because of that, it has a specific chemical formula. For water, the chemical formula is H2O. And it can only be separated by chemical means, not physically broken apart. In other words, you need a chemical reaction to separate the elements in a compound. Compounds continued. They have their own chemical and physical properties. And that we'll touch on that in a second. So chemical and physical properties are different in a compound than the chemical and physical properties from the elements that they're made of. In other words, H2O is water. Hydrogen, in normal atmospheric conditions, is a gas at room temperature. Oxygen is also a gas at room temperature, both of which are extraordinarily flammable. They explode, they start on fire very easily. If you put them together in a 2-to-1 ratio, two hydrogens to one oxygen, it's a liquid at room temperature. And by the way, these two flammable gases at room temperature, hydrogen and oxygen, you put them together with two hydrogens for every one oxygen, and you get a liquid that is used to put out fire. Wait a minute, we've got two flammable gases, put them together in a 2-to-1 ratio, and we get a liquid that we use to put out fire. So that's a great example of how the properties within a compound are not just the properties of the elements that make up that compound. Moving on, the first substance that is not a pure substance is called a mixture. This is a combination of two or more pure substances. So it could be elements or compounds that are not chemically combined. They're simply mixed together, hence the term mixture. Substances that are held together by physical forces and not chemical. So only physical forces holding them together. And I apologize that this is covering up the words a little bit. Each item in a mixture retains its properties. That's what that says. Each item retains its properties in the mixture. So it's the same physically as it was before they were mixed. The greatest example is that we talk about is if you've ever drank some salt water, whether that's from the ocean or just water with salt that you boiled some noodles with or whatever, it tastes like water, but tastes like water that's salty. That's because salt water is a mixture. And so it still retains the salty taste of the salt and the watery taste of the water. It is quite literally just mixed up together. It's still salt and water just mixed up. All right. So this is a handy dandy chart that compares mixtures and compounds in terms of their composition, whether they're joined or not, their properties, their separation, and then it gives you some examples. So let's get right into it. A mixture's composition is variable, which from experimental design you should remember means able to change. So you can vary or change the amount of each substance in the mixture. A compound's composition, on the other hand, is fixed or definite. It is not variable. You can't vary or change the amount of each element in a compound. There's always 2 hydrogens and 1 oxygen in water. You can't change it up. So mixture has a variable composition. Compound has a definite or fixed composition that you can't change. Next one is the whether they're joined or not. And a mixture has different substances in it that are not chemically joined together. They're simply stirred up or mixed together. Whereas a compound has different elements that are chemically joined by a chemical bond, and only a chemical reaction can separate them. The next category is properties. A mixture has properties of the things that make it up. So each substance in the mixture keeps the properties that it already had, and those properties are evidenced in the mixture ultimately, even after it's mixed. Whereas with a compound, the compound has completely different properties from the elements that make it up. Again, that flammable hydrogen gas, flammable water, or flammable oxygen gas creates liquid water that puts out fires. Very, very, very different properties. As far as separation, mixtures are pretty easy to separate. You can either literally just filter them out if the filter's fine enough, or if it's a fully, we'll talk about homogeneous mixtures and solutions in a little bit, but you can separate those usually by evaporating the water out, because usually water is involved in those. So they're relatively easy to separate, whereas compounds can only be separated by using a chemical reaction to break the chemical bonds that are binding whatever elements are in there are bound together by a chemical bond, and only a chemical reaction can break that bond. Examples of mixture: we've got air, seawater, most rocks. Rocks are actually a mixture of different sand, bits of rocks, and other things that are going on around the same area. They mix together. It seems like it's like a chemical bond, but it's really not. And you've got for the examples of a compound, you've got water, carbon dioxide, CO2. Magnesium oxide is another compound, and sodium chloride, which some of you might recognize as being table salt. Those are all compounds. So just to get an idea of what's a mixture and what's a compound as far as examples. Now we're going to do a little practice here. So see how you do. I want you to really try to identify these and be honest with yourselves. This isn't graded. I just want you to try it out and see how you would do. Quick review. An element contains just one type of atom from the periodic table. A compound contains 2 or more different atoms that are joined together by a chemical bond, and a mixture is 2 or more different substances that are only physically joined together. They're just mixed up, no chemical bonds involved. And a mixture can contain both elements and compounds together. So let's see which of you are geniuses. First one, rocks, element, compound, or mixture. Rocks are a mixture. Second one, copper. Little copper wire there. Is copper an element, compound, or a mixture? Copper is an element. It's Cu in Latin, it's cuprum. It's on the periodic table. You can find it in the metals section. Jelly beans. This one's a little bit easier. Jelly beans are not only a mixture of different colors, but they're also a mixture of different chemicals. They've got, sugar and gelatin and all kinds of other things in there mixed all together. Table sugar. Element, compound, or mixture? Table sugar is a little tricky because table sugar is a pure substance, but table sugar is not an element. Table sugar is a compound. It has 12 carbon atoms, 22 hydrogen atoms, and 11 oxygen atoms in each molecule of table sugar. Diamond. Diamond, element, compound, or mixture? A diamond is an element. It's made up entirely of carbon, which is an element in the periodic table. Tea, element, compound, or mixture? Tea is a mixture. You got the bits of tea leaves, you got sugar and cream if you have it in there, and then some water. Salt. Salt is definitely a pure substance, but salt is also not an element. Salt is a compound. It's sodium and chlorine. So it's called sodium chloride. One atom of sodium, Na, one atom of chlorine, Cl, bonded together with a chemical bond. Excuse me. Neon gas, element, compound, or mixture? Neon gas is purely neon. It's an element. A salad. This one seems a little easier. It's not one substance. It's got dressing. It's got different kinds of vegetables. Salads are mixtures. Pure water. This is tricky. Pure water. No contaminants, just pure water. Is not an element. It is a compound. H2O. 2 hydrogens, 1 oxygen. Even if there's nothing else in it, pure water is still a compound. Aluminum. Stuff that makes our soda pop cans. Element, compound, or mixture? Aluminum is an element. Al, it's in the metals section as well. Lemonade. Think about what this is. It's got water, it's got lemon juice, it's got sugar. It's got to be a mixture. Silver. Silver is a pure substance, but unlike table salt, silver is an element. Its abbreviation is Ag. It's in the middle section as well. Sand. Many people think that this is like salt and that it's a compound, but it's actually a mixture of tiny little bits of shell and rock and dirt and other things. All right, so just a quick overview of the chart. Everything that we know about it on Earth is called matter. It's anything that has mass and occupies space. You've got pure substances, and then you've got mixtures. Mixtures are not pure substances because they have variable composition that can change. Pure substances do not have variable composition. It has to be fixed. So that's on the other side here. And the two types of pure substances are elements and compounds. And that's just whether we can separate them into simpler substances. With compounds, we can. It requires a chemical reaction. With elements, we can't unless we do a nuclear reaction. Now, this next part, the two types of mixtures are what we're about to touch on. We've got heterogeneous and homogeneous. So let's go into that. The two types of mixtures. Homogeneous is the first type. Homo sapiens means like the same as we are now, and homo means same. With a little more awkward maybe topic that we don't talk about quite as much openly in society, homosexual couple versus a heterosexual couple. Homo literally means same, so that means two people of the same gender. Heterosexual means different, so it's one male and one female in a couple. It's the same thing that applies here. Homogeneous are mixtures in which molecules are mixed up in an even distribution. Solutions are the main example of a homogeneous mixture, and those are mixtures that appear to be a single substance. Like salt water appears to be a single substance, but it really isn't. It's salt and water, but it's just dissolved in. In any solution, you have two things, a solute and a solvent. The solute is the substance that's being dissolved. In this case, in the example of salt water, the solute is the salt. And then the solvent is the substance in which the solute is being dissolved. So in salt water, water is the solvent and salt is the solute. As a matter of fact, water is considered the universal solvent because it dissolves the most things of any other substance that we know. And in a homogeneous solution, particles do not scatter light. Light goes through them. So examples would be sugar water, lemonade, Kool-Aid, soda. Air is a homogeneous mixture. It's something a lot of people don't think about. So kind of seems like a pure substance, but it's not. The next type is heterogeneous. Remember, in a couple that's different genders, heterogeneous have molecules that are not mixed up in an even distribution. As a matter of fact, they settle out to the bottom. Parts of them are heavier and they sink, and parts of them stay at the top. That's why they're called suspensions because they suspend in layers. In a suspension, particles are ultimately dispersed, but then they will settle out into layers. So the one thing that I like to think about in this is like Italian dressing. You got to keep shaking it out. Otherwise, the seasonings and the oils and vinegars will be in different layers if you leave it sitting on the table for a while. So the particles in a suspension can scatter light, and they can usually be filtered using a filter. Examples of this would be a snow globe, sand in a bucket of water, muddy water, anything that you have to keep shaking out to keep it mixed up. And then the last one is the half and half in-betweeners. These are the colloids. They're a mixture of tiny particles that are bigger than those of a solution, but smaller than a suspension. So they're in the middle ground here. They do not settle out over time. They do scatter light. So they're like like the solutions, which are homogeneous. They do settle out, but like suspensions, which are heterogeneous, they also scatter light. So they do like characteristics of both. Examples of this would be mayonnaise, milk, gelatin, whipped cream. It's not going to let light pass through it, but it also doesn't settle out into layers. And there's a little bit of controversy with like how they should be categorized because there's so much in the middle. But that's the bottom line, is they're kind of like the half and half types of mixtures. So remember, you've got matter, which is pure substances, and then mixtures. And mixtures are either heterogeneous or homogeneous mixtures, or possibly colloids. And then you've got, I'll walk you through the chart again. So matter is either pure substances or mixtures. Mixtures are either heterogeneous or homogeneous, and somewhere in this middle ground here would be colloids. Then the pure substances, they're either just one element or they're more than one element, and so they're a compound. But they're pure substances, and you can't divide them out without some effort being put in. So that's the end of this presentation. Hopefully that's helpful for you. Go ahead and move on to the next assignment.